Think about what you know before you learn something new, and then maybe they'll stick better. Okay, so have you ever noticed that when a plane flies overhead or an ambulance passes you from behind or a train passes by, the sound of the siren or whistle changes, not just in volume, but in pitch. A change in pitch is a change in frequency. When the source of the sound comes closer to you, the pitch or frequency of the source seems to increase. When the source of the sound travels farther from you, the pitch or frequency of the source seems to decrease. The actual Doppler effect has nothing to do with volume, how loud or quiet something is, but it has to do with pitch and frequency. Okay? So let's say this is the source of sound. So this is the source of sound. Let's call this is observer 2. This is observer number 1. So this is the direction of the source moving. Here, the source is moving away from observer 2, so therefore there is a lower frequency heard by observer 2. So as we can see, the visualization of these sound waves, they're less frequent, lower frequency as it moves away. Now, as it moves towards observer 1, we have greater or increased frequency. We have a higher frequency, seems to be observed. So therefore, higher frequency heard by observer 1. Now, the actual sound waves of the source are not changing. The actual waves from the source do not change. So I'm saying this twice. That's probably something you should write down. The actual waves. The actual frequency of the source does not change. Only the perceived or apparent frequency changes. This is what I wanted to show you. This is what Sheldon thinks. This is what he would have said if he was in the classroom and had to make a poster.
Hey Sheldon, there's something I want to talk to you about before we go to the park.
I don't care if anybody gets it. I'm going as the Doppler Effect.
No, it's not.
If I have to, I can demonstrate. So what time does the costume parade start?
The parade?
Yeah, so the judges can give out the prizes for best costume. You know, most frightening, most authentic, most accurate visualization of a scientific principle.
Oh, Sheldon, I'm sorry, but there aren't going to be any parades or judges or prizes.
This party is just going to suck.
Oh, come on, it's going to be fun, and you all look great. I mean, look at you, Thor, and oh, Peter Pan, that's so cute.
Actually, Penny, he's wrong.
Time Peter Pan!
Okay. So, oh, but wait, he probably gives his actual definition, doesn't he?
I got a handful of pixie dust with your name on it.
No, you don't. I hate what Sheldon's supposed to be.
Oh, he's the Doppler effect.
Yes. It's the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer. It's the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer.
Perfect. The apparent change of frequency based on relative motion between the source and the observer. Excellent, Sheldon. Oh, once more.
It's the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer.
Oh, sure, I see it now, the Doppler effect. All right, I got a shower. You guys, make yourselves comfortable.
Okay.
Okay. It's good. Okay, so when the true frequency of a sound source is changed, so that an observer hears a different apparent frequency, as they move relative to each other, it is known as the Doppler effect. So make a note, it has nothing to do with volume change. Things do get louder when they get closer to you, but that's not the Doppler effect. We're looking at the change in frequency, that change in pitch. Okay, so then this is our equation for the Doppler effect. Now it's really important that we pay attention to the signs, to what each thing is. So take out your formula sheets. Okay, under waves, you should find this one. Okay, so you do have this, but memorizing what each thing is will be important. Okay, need to memorize this. This is on data sheet. So F is the apparent frequency. So that's what it seems, it's perceived by the observer. Fs is the true frequency that's produced by the source. So regardless of what is perceived or not, this is Fs is the true one. Okay? V is just the speed of sound waves. And generally in all of these questions we're going to be looking at the speed of sound in air. So that's about 340 meters per second. It will change depending on the temperature of the air. So most of your questions will tell you the speed of sound is 345 or 340. The reason why it changes a bit is because the air temperature. Okay? So this is the speed of sound waves, and just like, you know, like this is in air generally. Okay? And then Vs is the speed of the source relative to the observer. So me running down the hallway, Vs would be the speed of me. Okay? So how fast that actual object is moving. Now, see how this formula is written? It's written F is equal to V divided by V plus or minus Vs, all multiplied by Fs. So the plus or minus depends on the question. So here, you'll need to memorize this as well. So if we use a plus, if the source is moving away from observer, and use the minus if the source is moving toward the observer. So this you'll need to memorize because it won't be on your data sheet, but you're going to need to know it for your questions.